At the end of the lesson, you are expected to define a linear model, identify the parameter of a linear model, and appreciate the significance of identifying a linear model. Let's start our understanding by noting that a linear model is a function that maps input attributes to target value. So before in our lesson, we learned about how to map different points from a certain point to a certain point. So the link is given in the description below. So for example, let's use our example in lesson number 15. So if you haven't yet watched lesson 15, again, the link is given in the description below, because understanding this lesson would be more meaningful and significant if you've watched lesson number 15. This is just a continuation of lesson number 15. So for our attributes, let's use the numerical value of the years from 2015 to 2019. So if you could remember, we had a problem which is about a sales in millions of a certain company from year 2015 to year 2019. So of course here we can also say years since the business opened until 2019. So because the business started in 2015, so this definition of the attribute year does not make any difference since the range will always be the same. So this range is 4 years. That is, by subtracting 2015 from 2019, we could get 4 years. So 2019 minus 2015, then we have the range of 4 years. Okay? So how do we then define a function given the fact that the attributes are already known? So generally speaking, the function will take as an input x. In our case, we have years. So let me write here. I think I need to use another color. So, okay. So we have here years. And this will return y, which is the sales in million. So let's write here sales. Sales. This is in million. Million USD, okay? Million. Okay. Now, so we plug in the value of x, and every time we plug in it, this results to a certain value. So for example, when we plug in, or when we input 2015, then it corresponds to 10 million in USD for the value of y. So for 2016, we have 15 million that is in USD for 2016. Okay, so this illustration can be stated in other words. So we can say y is a function of x, and that in mathematics it can be written as like this. So we have y is equal to the function of x. Sorry, f y equals, is it clear? Okay, let me write it again here. Y is equal to, okay, y is equal to the function of x. So what does this mean? So it means that if we plug in any value of x, this will result to a certain value of y. So should you want to know more about the function, you can evaluate the function of x. How are we going to do the evaluation of the function of x? So if, for example, fx is equal to sin x, or we could say f, the function of x, is equal to x. So we can compute any value of y for any value of x. So it means that if we plug in a unique value of x, it results to a certain value of y. Okay, so for example, if we're going to write here 2017, it will result to another different value of y, and it's the same with 2018. It will result to a certain value of y. So shall we say, for example, we have here 17 million. And then for 2018, we could have 18 million. Okay, so given this situation, we should not treat a linear model as defined and confined in a box. So as you could see here, it varies. So for a certain year, it has its own value. For 2016, it has its own value. So it means to say that it is not confined in a certain box. So what's the meaning of this? What this means is we should be more flexible, because in some cases, our model is accompanied with a set of associated parameters. So for clearer understanding, let's have y equals ax. What's the meaning of this? So in this example, we have a parameter a. Let me underline that. A. That must be properly defined. So defining here means we should identify the exact value of a. So a here can be, it can be 1, it can be 2, it can be 3, it can be 4, it can be 5, and so on and so forth, depending on a certain situation. So it varies on a case-to-case basis. So as you could see here, when you have here a, this really acts as a constant, and the value of x may change depending on what value we're going to give x, and of course y, because it's the result of a and x varies depending on the value of x. Again, I want to repeat it that a here is a constant. It does not change. X changes depending on what value we're going to give it. And the result of y will depend on what value we have in here. So learning model parameters from a certain dataset is a fundamental thing to do in machine learning. So when I say certain, it means a suitable dataset, not just any dataset. Let me write that, suitable, so that you will not be able to forget this. Suitable, as opposed to is not equal to any. Okay? So it seems like, it's like we do not just choose any dataset, but it is a suitable dataset. Okay, so before we go into linear regression, so we have undergone, or our dataset have undergone or has undergone different processes, just like, for example, cleaning, and then we're going to identify the duplicated items and some outliers. So after all these things are done, then we could identify if our certain dataset is a suitable dataset wherein we could do this process, the modeling. So here in our case, we can use y. Let me write it here. Y is equal to f. Then we have x. Okay, so maybe you would like to ask me, what does this mean? Does it mean a very different thing? Because just a while ago we said, or we only showed y equals a function of x, and now then we had this one. So what's the meaning of this? Are they connected? Of course they are connected. Just like what we have said here, that a acts as a parameter, here also acts as a parameter. So how do we read this one? So, or what does this one mean? So this means the function of x for every value of, okay, so again. This means that this means the function of f that acts on x and has a parameter a. I want to repeat that. The function of f, or y, is equal to the function of f that acts on x, which has a parameter a. What is this for? Why do we have to study this? Let's view this on a real-life situation. So, for example, we have John, who is fixing his monthly budget. As of the moment, he's working on his electricity consumption. He has a statement of billing from an electric company that shows that the kilowatt hour or the kilowatt per hour he uses for each month. With this information, he already knows that the rate is 10.5 cents per hour. But the problem is he doesn't know yet how much it costs per month. So with this, he can actually use a linear model to write equations that can help him predict the cost of his monthly bills. So after all being said and done, let's try this. How do we define a linear model? Why do we need to define the parameter of a model? Do not forget to subscribe, like, and share. Please click the bell button to be notified every time we have a new session. See you in the next lesson.